Hi there, this is Dr. Coring, and this is a tutorial calculating units, whether it's heparin or insulin, and trying to determine the flow rate when we have to calculate drops per minute. So go ahead and try to solve this first question. You can pause the video and then we can compare answers. All right, so first thing that I always do is look to see what unit I'm solving for. That will give me my stop and start unit. So it looks like flow rate and drops per minute. So the drops on the top is how I start. And then when I have minute on the bottom, that's when I can stop and multiply across and divide by the bottom. So we have drops. And looking in the question, I don't see drops listed anywhere, but I do know drop factor and the number will have drops per milliliter tied to it. So that will be my drops that I will bring. So 15 drops, 1 milliliter. Next is milliliters. So the 250, and it comes with 5,000 units. And now we need a unit. We cancel out our milliliters. And I know I keep going because, again, I'm trying to get to minutes and I have unit down here. So next is 2 units per kilo. And now we need to cancel kilograms. So I see pounds, but I don't see kilogram anywhere. So I'll add a common conversion to this question. So 1 kilogram is 2.2 pounds. All right, get those canceled out. And then the weight will come with a bachelor, which is 1. And everything is canceled out, but I'm in a dilemma here because I need minute as a unit. So one thing I could do is just kind of plug it in down here and see if there's anything in the question that would plug into that spot. So I see actually 15 minutes right there. So that would give me my minute. And now that I'm looking at it, this 2 units per kilo, although it's not right next to each other, this was actually a trio. So we're doing a dose of 2 units per kilogram over 15 minutes. So really the 15 minutes should have been there. But I didn't catch that at that point, and so I had to troubleshoot at the end there. But you know, sometimes things aren't right next to each other, and you have to kind of go back and look at it after the fact. All right, so we have minutes on the bottom, and then we have drops on the top, so we can go ahead, multiply across, divide by the bottom. So 15 times 250 times 2 times 178. And that gives us 5,000 divided by, so we need 5,000 times 2.2 times 15. And that gives us 1,65000. We can cancel out equal amount of zeros on the top and bottom if they're present. This makes our little calculator fingers work a little less. So 1,335 divided by 165 gives us 8.09, 9 drops per minute. And this is not feasible to do 0.09 of a drop, so we would need a whole number. And we would round to a whole number. So if we moved our tenths digit to a 1 based on this 9, we'd have 8.1, which would still mean that our whole number would be 8. So 8 drops per minute. All right, here is the next question. Try to solve this one. Go ahead and pause the video. And then once you're done, hit play. All right, so this one, go to the very end, looks like again we're solving for drops per minute. So we'll have our stop unit, or not stop, but our start unit is drops. Look for it in the question. I don't see it anywhere. So we have to kind of look for some code words like we did before. So micro drip tubing is a hint. Micro drip means that the drop factor is 60 drops per milliliter. Another term you might see that represents the 60 drops per milliliter is burette. So if you see burette or micro drip tubing, that means a drop factor of 60 drops per milliliter. So we'll go ahead and plug that in. And then next we have milliliter. And I don't see that anywhere, but I do see cc. So we will need to find a bridge of milliliters to cc's. So what is that common conversion? It's kind of a trick question. So 1 milliliter also means 1 cc. These are the same thing. So we can substitute cc for milliliter. So we have 1 milliliter, it's 2 units. And then we need a unit up here, cancel our milliliters. So we have 0.5 units, and per kilo per minute gets rid of our unit. So we have a minute that we need to keep, so we'll not cancel that one out, but we do need to get rid of this kilogram. Look for it in the question, and we have 59. The weight is a bachelor, so it'll go over 1, so we'll cancel out our kilogram. We have drops on the top, minute on the bottom, so we can go ahead and multiply across and divide by the bottom. So we'll have 2 down here, and then we'll do 60 times 0.5 times 59 is 1770 divided by 2 is 885 drops per minute, which is not a realistic flow rate because counting 885 drops would be impossible over 60 seconds. So this is just, well, and likewise with the previous one, doing 8 drops in 1 minute would be an extremely difficult feat of just moderating that few of drops over 60 seconds. But these are for the math's sake. So 885 drops per minute is the final answer. I hope this helps.